Welcome back, students. Today we're going to be talking about graphing in slope-intercept form, which is y equals mx plus b. In order to start talking about slope-intercept form, let's start with slope. Slope is m in the equation y equals mx plus b, and it's there to show the steepness of the line, and that's why we call it slope, just like a ski slope. Now, how steep it is going to depend on how much it's going forward versus how much it's going up and down. So, the slope of any non-vertical line passing through the points, now notice how they do this, x1, y1. So I've got my first point here, so I'm designating the x value of the first point as x1, the y value of the first point as y1, and the second point, x2, y2. Is going to be the ratio of the rise to the run. Now, the way we calculate a rise, how much it went up, is to do y2 minus y1. Since the y value is what goes up and down, we subtract them to figure out how much that was. So let's imagine that y1 right here was at 3, and y2 was at 5. So 5 minus 3 would become 2. And that's how we figure out the rise, by subtracting those values. Same with the run. How far forward did it go? We take the second value, subtract the first, and it'll tell us how much it changed in the x values. So slope is calculated in this fashion. It's the rise over the run, in other words, the change in y over the change in x, which we can calculate by doing y2 minus y1 over x2 minus x1. When a line rises, now this is always going from left to right. That's how we read. When it's rising, the slope will be positive. When it falls, the slope will be negative. So let's find the slope from each of these lines. We've got a diagonal line right here. Now, one approach you could take would be to draw a line going first straight across till it's directly underneath the other point, and then draw a line straight up towards it. We can then count or calculate how long this line is. So in this case, 6 and 4. Slope is supposed to be rise over run, so we would have the rise of 4 over the run of 6. The other approach to this is our equation of y2 minus y1 over x2 minus x1. Now, I show both of these methods because you can't always count. Sometimes you'll have graphs that won't lend themselves to you being able to count squares to figure out slope. So we need to be able to use this formula of y2 minus y1 over x2 minus x1 in those situations. So notice where these numbers came from. For the y2 minus y1, we had 2 minus negative 2, and x2 minus x1, 3 minus negative 3. We had our first point and our second point, and that's how I figured out which one is y2, x2, y1, x1, all of that. As I do that subtraction, we get 4 over 6, exactly the way we counted. This would simplify into 2/3. Okay, now we're going to say 0 and 2, 0, 2, that's our first point, so x1, y1, to negative 1, x2, y2. So as we begin doing that, y2, the negative 1, minus y1, 2, 2 minus 0, which would give us negative 3, 2. That won't simplify, so that's our final answer. All right, so those are two ways that you have for calculating slope. Make sure you can use both. Make sure you can draw these lines and count the squares for those situations in which that is available. It's a very fast way of doing it. Make sure you can also just use the points, because you're not always going to be able to count squares. All right, now let's find slope from a table. Just keep in mind, it's always the change in y over the change in x. So we notice how y is changing. Y is going down by 6, and x is going forward by 3. So the change in y over change in x should be negative 6 over 3. Negative 6 divided by 3 is negative 2. So that's the slope of A. For B, just look at y, so going from 2 to 2, so the change in y is 0. X goes from negative 1 to positive 1, so that would be forward 2. So the change in y was 0, the change in x was 2. 0 divided by 2 is 0. So this has a slope of 0. Notice what created that slope of 0. The fact that y was always the same number, that there was no rise. All right, now in 3, the change in y, we go from negative 3 to 0, so that means we went up 3 places. For the change in x, we go from negative 3 to negative 3, so it didn't change, so that will be 0. Now we cannot divide by 0. That's impossible, and it's because it doesn't make any sense. To divide by 0 here would be to say, take these 3 things, divide them into 0 groups. Now how many are inside of each group? It just doesn't make sense, and so we call this undefined. Table C has an undefined slope. We got 4 kinds of slope. There is a positive slope when the line is rising. Our slope calculations will always give us a positive number here. We've got a negative slope when it's going down. If you calculate the slope here, it'll give you a negative number. A slope of 0, we noticed this in the past example where y was never changing, and that's what's happening here. When it's a horizontal line, y isn't changing, it's staying at the exact same number. That creates a slope of 0. When it's a vertical line, that creates the situation that we saw where x didn't change. So x isn't changing, so there's no run, there's only rise. That creates a vertical line, and that's an undefined slope. So let's identify some slopes and y-intercepts from equations. Now, I said earlier that the slope-intercept form is y equals mx plus b. So we just need to figure out what m is and what b is. In this situation, 3 is in the m spot, m is 3. Remember that it needed to be plus b. Since this is a minus 4, we're going to say that b is negative 4. Okay, because I could rewrite this top equation as 3x plus negative 4, and it would mean the same thing. So b is a negative 4. Okay, in this one, I don't see the x, so I'm going to rewrite this a little bit so I see the x, so I know exactly what the slope is. Okay, so our slope here would be 0. We saw a situation up here in this equation in which y was never going to change. It was always going to be 6.5. That's what creates that 0 slope. So our slope, is 0. The y-intercept, b, is 6.5. Make sure to be linking these words. Either add a little note for yourself or do some exercises to make sure that when someone says the word slope, you're linking that with rise over run, change in y over change in x, m, that the y-intercept is b. Okay, these words need to be associated. You need to know which ones go together. Now, this one, it looks like I can already see the slope, and it looks like I can already see the y-intercept, but because it's not in y equals mx plus b form, I need to be careful. So I need to make sure I put it in that form first. So let's add a 5x to each side. Now what this is going to do is it's going to eliminate the 5x over here. Negative 5x plus 5x is 0. 0 minus the y is just negative y. And these are not like terms, so I can't combine them. So I just have a positive 5x with a negative 2. Okay. Now, we still don't have it in the right format because this is a negative y. Now, if negative y is a positive 5x minus a 2, then positive y should be a negative 5x plus a 2. Notice how I just changed the signs in front of each term in order to do that. So now it's clear for us to see where the slope m is. So slope is negative 5 and the y-intercept is 2. Now let's use slope-intercept form to create a graph. So we've got this equation right here. Problem is it's not in slope-intercept form yet. So let's put it in that proper form. So we're going to rewrite the slope in the form y equals mx plus b. In order to do that, I need to get x to the other side. So minus 2x from each side. We get y is equal to negative 2x plus 2. Once again, because these are not like terms, they can't combine, so we just have the negative 2x and the positive 2 as separate terms. Now we need to identify our slope and y-intercept. Well, this is just like what we did before. The negative 2 was in the m slot, so that's our slope. Notice here how I changed it to a fraction. I just put a 1 under it. This serves the purpose of helping us to know what's the rise and what's the run. So our rise is a negative 2, so we'll go down 2, and our run is a 1, so we'll go forward 1. The y-intercept is a 2. Now we call it a y-intercept because that's where it crosses the y-axis. So our equation should cross the y-axis at 2. And then using our slope, we can figure out the next point because slope is going to tell us a direction to move in. We need to go forward 1 and then down 2 places. And that'll tell us where the new dot is supposed to be. Now that we've got 2 dots, that's sufficient to draw a line. We've now successfully graphed the line 2x plus y equals 2. All right, so now let's do it given a verbal description. We've got this linear function g that's modeling the relationship in which the dependent variable, this is another vocabulary word that we heard earlier, dependent means it's the y, okay, increases by 3 units for every 1 unit that the independent x variable increases. Now we want to graph g. G is going to be the name of our function when g of 0 is equal to 3. So in other words, when the input is 0, when the x is 0, the output is 3. We want to identify the slope and y-intercept and x-intercept of the graph. Okay, so let's start by finding the slope. Slope should be change in y, which is 3, because it told us the dependent variable increases by 3 for every time x changed by 1. Okay, so the slope must be 3 over 1, which is 3. Great, we've got a slope for this equation. All right, so now to find the y-intercept. The y-intercept is where it should cross the y-axis. Well, let's go ahead and just graph this point that we have right here, where the input is 0 and the output is 3. If we were to graph that, it would show up right here on the y-axis. So because g of 0 equals 3, that must mean that b is 3 because that's where it's crossing the y-axis. Now, if we want to graph this as a line, we turned this point into a point on the graph, and now we can use our slope, which is 3 over 1. So going up 3 and then forward 1. Okay, so now we've got those. We can graph a line straight through it, and we've got our equation. I hope this was helpful. Good luck.